Good morning, everyone. My name is Shawn Marshall. I'm a glaciologist at the University of Calgary in Canada. And right now I'm seconded to the Government of Canada, working with Environment and Climate Change Canada as the Departmental Science Advisor. So this is kind of our Ministry of Environment and Sustainable Development within Canada, working with water, wildlife, biodiversity, weather, and climate. It's really my honor to be here today at this second High Mountain Summit. I had a chance to attend the first one a year ago in Switzerland, and I feel this topic is very close to my heart. So today I wish to speak a little bit about the glaciers of Canada and give the story of what's happening in our mountain regions in Canada. And I think it's a very similar story to Colombia and the Andes and the world, in fact. The glaciers of Western Canada and Arctic Canada are changing dramatically. They're very far out of equilibrium with the climate. And in fact, the changes go beyond what you would just expect from the warming alone. We can't explain how much the glaciers are changing just from the temperature change. There are a lot of feedbacks and indeed regime shifts happening with the glaciers in Canada that I will share a little bit with you here. And I think a lot of this is relevant to many of the world's mountain regions, even in fact relevant to the fate of the Paramos. So I will try to tie this in a little bit near the end of the presentation. But to start with the global story, I think many of you know this. Glaciers are thinning almost everywhere in the world. This image is from the World Glacier Monitoring Service, and this shows from 1950 until 2019, the thinning in the red or the thickening in the blue of a composite of global glaciers. So they put together a bunch of index glaciers from different continents. And you can see that almost all these years, we're in the red. These glaciers are thinning, they're losing mass, they're retreating. And you can also see this very strong acceleration of retreat, the increase in thinning from maybe the early 1990s through till today. This last decade was very punishing on these glaciers. And the units here, this is -1 is 1 meter of thinning. So this is the average amount of thinning across the whole glacier. If you look at this as a cumulative change over these almost 70 years now, you see different stories slightly in different parts of the world. The one thing I wanted to draw to your attention here is this cumulative thinning of glaciers in the orange line. This is Western Canada and the Western US. And this is one of the worst places in the world, it seems, for glacier thinning. It's a cumulative thinning of almost 35 meters over this time. And you can really see how this is concave downwards, how this rate of increase is getting worse. The thinning is getting worse for these glaciers. They don't actually they have the southern Andes here in purple. They don't actually show the tropical glaciers. I wish they did, because I would like to compare, because I know the glaciers in Colombia and in tropical regions are not doing very well also, and I expect that they have a thinning of probably 20 meters over this period. And in fact, many of these glaciers are quickly disappearing from our landscape. And you can see this in different ways. The scientists tend to measure the mass balance of these glaciers and the thinning and thickening, and they average this to some rate of thickness change over the glacier. But as a tourist or as a mountaineer or as someone to visit these sites, you also see this change very dramatically. So of course, this is one of the signature glaciers of Canada called Athabasca Glacier. It's in the Columbia icefield of Western Canada. And this is from about 100 years ago, 1918. And this is essentially what it looks like when you go here today. And this is a story that you can see in all of the world's mountain regions, this kind of glacier retreat. It's mattering for global sea level, and it's affecting our regional water resources. I want to go to a couple of my field sites now and say just a little bit more about, some more detail on exactly what's happening with these glaciers and some of the feedbacks I mentioned, or the regime changes that I've mentioned. So I will take you to Head Glacier in the Canadian Rockies. When we think of a glacier, we tend to think of it as this beautiful white surface, ice with snow on it. But in fact, by the end of the summer on these glaciers, we're completely losing our snow and ice. We're left to many glaciers in the Canadian Rockies with the surface that has no snow cover at all anymore. And so even to the very highest elevations of these glaciers, it's a bare exposed ice. So in a way, the glacier is being kind of decapitated. It's losing all the snow that nourishes this glacier by the end of the melt season. And so we have this system that's far out of equilibrium with the climate. It's not getting the nourishment, and it will continue to thin until it probably will disappear from the landscape in this situation where there's no extra snow. At the same time, we also have these glaciers getting very, very dark each year, and more so. So I want to say a little bit more about that. I'll come to that in 2 minutes. Overall, in Western Canada, we've seen an area loss in the Canadian Rockies. Between 20 and 30% of the area of these glaciers disappeared from 1985 to 2005. And we will revisit this in 2025. And I think it's probably another 25% of area change in these glaciers. And finally, this image here, this shows some projection going forward of how the glaciers will change in the coming decades to the end of the century. And even if we sort of stabilize the climate right now at the current climate conditions, these glaciers will continue to thin and retreat and lose about 50% of their mass. That's our estimate for Western Canada. But if we continue with climate change as projected, it will be more like an 80 or 90% of the glacier loss in these systems. So already they're so far out of equilibrium that we really are losing the ice, and it will continue. And then it's a question of whether we have any ice left really at the end of this century. The albedo is the reflectivity of the glaciers, and this is one of the big things that's one of the feedbacks, which takes a bit of temperature warming and makes it even harder for the glaciers, because as we get warming climate, the melt season lasts longer. We start melting sooner, and we keep melting into later in the season. There's of course more energy, which gives you increased sensible heat flux and long wave radiation that just accelerates the melt. But one of the big impacts is you're concentrating impurities. You can see how dirty this glacier surface is. We're concentrating dust and sediment and black carbon on the surface of these glaciers. And instead of being, we think of snow and ice as being very reflective. So an albedo of 0.8, maybe 80% of the sunlight that comes in will be reflected. But it's of course much more serious than this. As you get darker and darker, we're getting more like a 0.2, like at 20% of the solar radiation only is being reflected, and up to 80% is being absorbed. So that's increasing the amount of sunlight that's being used to melt the glaciers by a factor of 4 from the early melt season. One of the changes we're getting that I call a regime shift is that as things warm, we're starting to get more summer rainfall instead of snowfall. When you look at a graph like this, we see the albedo jumping up in July and August. This is from summer snowfall, like this picture. I go back to it, like this picture here that blankets the glacier. This is an August image after a nice summer snowfall. This brightens the glacier, and snow overall increases the albedo of our glaciers by about 10%. As we shift from snow to rain, this will get much worse, and we will start to lose more of this ice. And that's a very strong feedback to the melt. I replicated this picture here as well. This is, you can't see it so well, but in this image on the right side, we have what the glacier looks like after a rain instead of a snowfall. So beautiful summer snowfall on the left. Here, you don't see the surface expression of the rainfall, but if you dig down into the snow, and we're busy measuring the temperature and moisture and the water content of the snow, there's this layer of just slush below where the water from this rainstorm there's an overnight rainstorm of about 20 millimeters, and it just really soaked the slush, turned it to slush, and this really accelerates the melt of these systems. So the snow protects the glacier, it makes it brighter, adds mass, and the rain is almost the opposite effect. Another effect we see with albedo is the effects of wildfire, and this is very relevant globally. It's very relevant in the Andes as well. Some details here, but this is a survey of the glacier surface over 2 weeks periods, every 2 weeks apart in summer of 2017, 13 July in the blue when it was still snow covered, 26th July, 9th of August, 22nd of August. You see the glacier getting darker and darker through the melt season. By the middle of August, we were setting new records for how dark this glacier was. Albedos of below 0.1. This is darker than, it's the same color, the same absorption as the ocean. I mean, it's one of the darkest measurements I've ever seen for glacier ice. And these data are along some centerline transect of this glacier we're studying. And I put in too many numbers here for you to look at. But what happened this summer is that it was a very big wildfire season in British Columbia and Western Canada. And this glacier site in the Canadian Rockies is downwind of all these wildfires. And we had a lot of deposition of carbon, black carbon on the glacier. We had 4 to 6-fold increases of total carbon and inorganic carbon on the glacier during this period. So this was black carbon from the forest fires and also some organic carbon from the forest fires that was being deposited on the glacier and really darkening it. This is something that's been seen on the Amazon fires as well. When there was a bad Amazon fire season 2 years ago, the trade winds blew a lot of this into the high Andes, and measurements on glaciers, in this case in Bolivia, have recorded very similar findings. The glaciers getting darker, and I think this is a very, very disturbing impact of global warming, that we have increased wildfire, and then this in turn reaches our high mountains, and it's changing the surface and darkening our snow and ice, and leading to even more retreat of these glaciers. Just one or two last points on what I'm calling the very strong feedbacks or regime shifts in the glaciers. And this is a very detailed image, but it's very powerful, so I'll spend a minute on it. This is from a site in northern Canada near the Yukon-Alaska border. It's a cold site. It's a place where glaciers are deeply frozen. Their temperatures are well below zero, or they used to be well below 0 degrees Celsius, the melting point. Only the summer warming, we would get 1 or 2 months of melt, and below that it stayed below the melting point. So a lot of meltwater from the surface would percolate into the system and refreeze in the system. This is showing from 1965 to 2019 a model of the temperature evolution of the firn, the upper 20 meters of the glacier. Firn is snow that's slowly turning into glacier ice. This is a site where we developed some ice cores. We acquired some ice cores to look at environmental change. And when we went to collect an ice core in 2018, we encountered this deep, warm, wet snow and ice. When we pulled up the ice core from about 30 meters depth, it was dripping water. And we didn't expect this at all. We thought we would have cold snow and ice down here. So we looked into this further, and modeling this glacier system, and we see that there's been this shift over the past 10 years from cold firn, temperatures of about -10 at depth, to temperate conditions, melting conditions. So we had so much meltwater in the past 10 years that this meltwater percolated to depth. When this meltwater refreezes, it releases latent heat, and this has warmed the entire system, such that we now have a glacier that looks more like a tropical glacier, or a glacier in the Canadian Rockies that's at the melting point throughout. And this is a very big, very true regime shift for these glaciers. It means they're warming up, the ice will flow faster, it will start to probably slide at the base. Meltwater that percolates will no longer refreeze. This is essentially taking these Arctic glaciers and making them look more like tropical glaciers. And my final point, I want to say a little bit and connect us a little bit into the tropical Andes in Colombia. With climate change, we think about warming, of course, but we also see some sense that water vapor is increasing in the troposphere. And that's an expectation with an increased hydrological cycle, and also warmer air can hold more moisture. And we don't have very good measurements of this, but models suggest that This is looking at decadal trends in water vapor and vapor specific humidity. This is all above zero, so we're seeing increases in humidity at all elevations and possibly more at higher elevations. It's a very interesting question of how specific humidity is changing at different elevations and in the mountains. This matters because the more humid atmosphere emits more long-wave radiation back to the surface. It increases the latent heat flux. For tropical glaciers, there's a real chance that this might change the regime from kind of sublimation dominated to more melt dominated, which would really, again, be a regime shift, change how the tropical glaciers melt, change their energy and mass balance processes. This could also probably lead to changes in cloud and precipitation. At our site in the Yukon, we see this very strongly, an increase in specific humidity over the past 50 years. This has led to much more net energy and increased melt. This is actually more than temperature even been the main driver for that change in regime from a cold glacier to a temperate glacier at 0 degrees Celsius. And I think this matters a lot for the glaciers in the tropical Andes, also for the Paramo, because if this is real, if we're really seeing increases in humidity and more at the higher elevations, then this has implications for how the water balance and energy balance will work in the mountains for the glaciers, but also for the Paramo. It could lead to more precipitation and more cloud. It probably leads to a higher elevation range for the Paramo. It could lead to more moisture and less evaporation, but I think that really needs to be studied with very careful measurements. And so I did want to finish with this to bring it a bit back to Colombia, where the honor of contributing to this meeting. I think it's clear there are many changes in our alpine environments, many of these well beyond the direct effects of warming. The way glaciers are melting worldwide can't be explained by just the warming. There are these other changes as well, and things like albedo and the energy fluxes and the moisture in the atmosphere, how that's changing the energy balance. I think changes in this moisture regime, the cloud cover, need to be better understood, and how that's changing with elevation needs to be better understood. The models kind of have a simplified view of this, but they don't resolve the mountain environments very well. So I think for environments like the mountains of Colombia, but also in northern Canada, we really need sort of more measurements of how things are changing with elevation and really monitoring the effects of faraway forest fires and the effects of changes in the evaporation and transpiration and the cloud forests. And these all are very connected for the glaciers and for the Paramo. And so I wanted to finish with this note and thank very much to IDEAM and to the Ministry of Environment and Sustainable Development for hosting this meeting. I really look forward to hearing more and learning from these sessions. And I really do feel very much that there's a strong connection between our changing mountain environments. And even though the snow and ice of Canada look very different and feel very different from the Paramo, I feel like these are very connected in how these are changing and how these are very vulnerable to the climate change we're experiencing right now. Thank you very much.